Hello, guys. It's the math tutor back here. My name is Maria Lucia Ramirez, and I'm trying to make videos to help you guys understand certain topics. So, today's video is a practice problem from a previous final from my university, and we're going to be going over QR factorization. If you want to get a grade like this on your linear algebra final, follow along in this video. So, for the final, especially, we got to use a formula sheet, and what we put on this formula sheet was pretty important. For this problem, I would be using this section of the formula sheet. So if you guys want to screenshot this, it's the Gram-Schmidt and QR factorization. So I'm going to label this V and V2, and this is going to help us set a basis for our QR factorization. So using V1 and V2, we can find our columns of Q. So the first column of Q is going to be normalizing our first row of vectors. So it's going to be Q1 equals V1 over, and so this is going to be 1, 2, 0, 0, and then 1 magnitude of V1. So 1 squared plus 2 squared is, let's just, so we found our first column of Q. It's right here. So next we would need to find Q2. So Q2 would equal V2 orthogonally over the magnitude of V2. So now this is going to be our formula that how we find V2 orthogonalized. So we're going to be using this, and V2 is going to be equal to this right here, and it would be 0, 5, 2, 4 minus the dot product of Q1 and V2, taking the dot product of, we have Q1, 1 over root 5, 2 over root 5, 0, 0, dotted with V2. So we have 0, 5, 2, 4. So I'm going to do the dot product over here. So 1 over root 5, 2 over root 5, 0, 0, dotted with 0, 5, 2, 4. And when doing the dot product of matrices, so we would do this times this. So imagine it was like this, and you were doing multiplying these together, multiplying these together. So what we get for the dot product, 0 times 1 over root 5 is 0. 5 times 2 over root 5 is 10 over root 5, plus 2 times 0 is 0, and 4 times 0 is 0. So we get 10 over root 5 as the dot product. And so we're going to take that dot product and multiply it by Q1. So Q1 is 1 over root 5, 2 over root 5, 0, 0. So this is what we're going to multiply. So this dot product over here. So multiplying this, it would be 10 over root 5 times 1 over root 5, which is just 10 over 5, which is just 2. And then 10 times 2 over 5. So it's 20 over 5, which is 4. This is what you get. And then you just subtract those matrices. So negative 2, 5 minus 4 is 1, 2 minus 0 is 2, 4 minus 0 is 4. So this is what you should get for V2 orthogonally. And in order to find Q2, we just need to normalize V2. So it's going to be Q2 and V2 over the magnitude V2. So in order to normalize it, we're going to take the magnitude of V2. So it's going to be negative 2 squared, which is 4, plus 1 squared, which is 1, 2 squared, which is 4, and 4 squared, which is 16. So this is just going to be root 25, which is just 5. So we're going to do 1/5 and then multiply that by what we got for V2. So -2, 1, 2, and 4. So this is what we get for Q2 right here. So Q is going to be the columns of Q1 and Q2. So since we have those two, so Q1 is right here and Q2 we found right here. So I'm just going to combine those two. So now we found Q. It is so easy to find R. So I wrote down the formula for a 3 by 3, but since we only have 2 columns, we only need to do a 2 by 2. So it's going to be this formula right here. And I would highly recommend copying this into your formula sheet. So this is the 2 by 2 matrix of R. So we already found all of these values, so we just need to plug them in. So the magnitude of V1, I looked back and found it was √5. So V1, √5. And then Q1, V2 is 10 over √5. And I found that here as the dot product, 10 over √5. And then V2 is just right here. And I found that as. So this is how you find Q and R. I hope you guys enjoyed the video.